to remember the chain rule. The easiest thing to forget is to use the chain rule on this. You are treating y differently than x because you're differentiating with respect to x. You're not differentiating with respect to y. So yes, the first step was y is equal to f of x. So what does this make it become? It becomes x cubed plus f of x cubed, not plus, equals 6 times x times f of x. Okay, nice. Now I take the derivative in terms of x. You're doing the derivative. You're doing d dx. You're doing the derivative in terms of x. So what's the first one? What's x cubed? What's the derivative? Is 3x squared. And what's the invisible chain rule thing? 1. And then what happens here? You get 3 times what? Yeah, you don't change it to the second times f prime of x equals, and then what do you have to use here? You have to use the product rule right here because it's two functions multiplied together, product rule. So the derivative of the first is 1 times f of x plus the first times the derivative of the second. The only difference in what Ms. McCullough writes out is that the derivative of x in terms of x is dx over dx, which is 1. So instead of writing 1, she writes dx over. It's the same exact thing, kids. So at this point, what are you trying to isolate? What's the whole goal? What are you trying to isolate? There is no y in there, though. And you're not trying to, we're trying to isolate y prime, right? Like this, the y primes. So if you want to isolate them, what do you have to do first here? What do you need to do first? Trying to isolate those. What do you do? We did it yesterday, and you did it for homework. What do? You want to eventually factor, right? But before you can factor, you need to get all of them on the same side. You need to get all of them on the same side. So you also keep in mind that that 6 gets multiplied in, right? Yeah. So let's, what do you get here? 3 times f of x squared f prime of x, like this. And then what should I subtract? Minus 6 what? 6 f of x, right? Yeah. Equals x f prime of x minus what? Oh, we want to, what am I doing? Yeah. I want to move that over, right? Minus, yes, hold on, minus 6x, I'll put it all on the left, okay? So we have our two pieces. There's that piece and there's that piece, right? So what's left on the right side? 6f of x minus what? 6f of x minus what? What have I not? There's one piece I haven't. 3x squared, exactly, David, right, minus 3x squared. Oh, you just brought that. I just moved it over. I haven't done. Okay. You need to get it all on the same side, right? Yeah. Now, what can I factor out? What can I factor out now? F prime of x, right? Yeah. What does it become? F prime of x times what? 3f of x squared minus what? 6 minus 6x. Yep, equals 6f of x minus 3x squared. Right. Now, what do I divide both sides by? Exactly. So now we have f prime of x is equal to 6f of x minus 3x squared over 3f of x squared minus 6x. Well, you know that y is equal to f of x, right? And what does y prime is equal to? What's the question, Noah? What did we just do to get from there? We took this and we divided both sides by it. We just divided it all out. That was what we factored what we wanted to stay and took away everything else. So what can we rewrite this as? What is another way to write f prime? Y prime. So y prime is equal to 6 times what? Y. Minus 3x squared over what? 3y squared minus 6. Yeah, done. There it is. You now have the derivative of that thing. Natalie and then Alex, yes?
Is it okay if you change it back to 1?
Again and again and again, all you need is a point and a slope. It never changes. In multivariable calculus, we're writing the equations of planes now. Guess what changes? Not much. You need 2 slopes and a point. That's it. Questing for flat things is very, very common in all of these fields. Now that's an implicitly defined function, so we're going to use implicit differentiation. What's easier generally to find, the point or the slope? Generally speaking, the point is. So you let x equal what? 2. So what do you get? 2 to the 4th plus 16y to the 4th equals what? 32? Yeah. What is 2 to the 4th? 16. So is that 16y to the 4th is equal to 16? Yeah. So what does y to the 4th equal? 1. So what does y equal? Ah, very good. So how many points have x equal 2? 2. There's 2 points. 2 points. So how many lines are we actually finding? 2 lines. So the first point is 1, 2, and what's the second point?
It's 2, 1.
Sorry, excuse me. Yeah, 2, 1, and what's the other one? 2, 1, and 2, So now we need to find the Slope. So to find the slope, what do we need to find first? And what kind of derivative are we talking about? Implicit, right? Because we're not isolating y first. Theoretically, could we isolate y on this one, actually? Could we?
Yeah.
Yeah, you could, but it's going to be easier not to. So if you do this derivative here, what's that substitution I want you to make? What does y equal? Yep. So what do you get here? So you get x to the fourth plus 16 f of x to the equals. So we take the derivative now. What's the derivative in terms of x? Oh, it's just 4 what? Plus, what, 4 times 16 times f of x to the what power? Times f prime of x equals what? 0. Very good. Hey, no one said 32. Yay. Maybe you were thinking it, and Natalie helped you out there. So it's 0. That is the number one most common mistake, is saying 32, and then it's like, no. What could I divide everything by at this point to make it a little nicer? Do it by 4, right? What do you get? X cubed plus 16 f of x cubed times f prime of x equals? So what do you end up here? You end up with f prime of x is equal to negative x cubed over what? Well, yeah, 16. I'm just going to write one more step. F of x what? Cubed. So we get y prime is equal to x cubed over 16y cubed. So there's our derivative. Oh, thank you. Yes, negative. So we had 2 points. How many slopes do we need to find? Well, we need 2 slopes. We're going to find 2 different. Could they have the same slope? Sure, they could be the same slope. Could like 2 lines be parallel? Sure, they could. But what's that first point? 2, 1, right? Yeah. So y prime at 2, 1 is equal to what? Negative 2 cubed over what? 16 times 1 cubed? What's that equal? What's on top? Negative what? Because that's negative times 2 cubed over is what? So if that's the slope, sorry, if that's the point and that's the slope, what's the equation of the line? Y minus equals x minus. Exactly. Now we need to do this, but what we have the point what? 2 comma what? Negative 1. So you get y prime at 2 comma negative 1. What's that going to be? Negative. Well, it's negative 8 because you plug in the 2 again, right? But then what's on the bottom? 6 times what? Negative 1 cubed. What is negative 1 cubed? So the slope this time is what? 1/2. So what's the equation this time? Y minus. I know it turns into plus, but y minus what? Negative 1 is equal to 1/2 x minus 2. And you could write this as this. It would be fine to write it like that. So do we get 2 different lines? We do. Here they are, right there and right there. But again, you're questing when you're asked for a line just for a slope and a point. That's it. Point and a slope, point and a slope. AP Calculus questions ask these things. Here's a function. Just as a side note, this thing right here, I think this is, did anybody graph this by any chance? Anybody know how if I asked you right now to draw me a picture of that, and what are you supposed to do on it? What's the question asking? Find y prime? Is that what it find dy dx? Okay, so you need to use implicit differentiation. So do that first. It should just be autonomic. What do? Y is equal to what? F of x. So you have x ln of f of x plus f of x cubed equals ln x. What rule do you have to use on this first one right here? What do you have to use on this one? The product rule. And remember, please do the derivative of the first times the second plus the first times the derivative of the second. Don't change the order. It's helpful to me. So what's the derivative of the first? 1 times ln of f of x plus the first times the derivative of the second. What's that going to be? What's the derivative of ln of something? Yeah? 1 over f of x, right? Times f prime of x, because you need to do the derivative of the inside. And then what's this next one going to be? Can someone just tell me what the next one's going to be? Mark, can you tell me what's the derivative in terms of x of that? What do you bring to the front? That's a 3, yeah. So 3 what? Yep, to the what power? Times what? So it's f prime of x equals, now what's the derivative of ln x? 1 over x. And in the notes you might say times dx dx, but again, what's dx dx? Is 1. Dx dx is 1. Dx dx is 1. Okay, so in this case, so Natalie, in this case, you could keep on writing it out. What do we want to isolate? I like using the highlighter. What are we trying to isolate? We want to isolate this, right? Now, Natalie, at this point, you had asked me earlier, could you substitute back at this point? Does it clean it up a little bit? Does it make it a little easier to write? Sure. So I'll let you do that. Let's just do that as an example. So what would this be? It'd be ln of y plus x over, well, it's x times y prime over y plus 3y squared y prime equals 1 over x. All I've done is I've resubstituted. Do you see where each of those pieces came from? Please ask now. Do you see that there's the y prime and there's the y prime? Everybody sees this, right? What are we trying to isolate? Y prime. So we need to get the things with y prime isolated or on one side. So what should we subtract and put to the other side? Yeah, we should take this and do what with it? Put it over there and make it what? Minus, not highlighter, but make it minus, right? Now what can I factor out of the left? What can I factor out? Not y. We don't, y can be there. What specifically do we factor out? Yeah. Y prime. Y prime. So what do you get? Y prime times what, David?
Y prime times x over y.
Yep. Plus
3y squared.
Exactly equals 1 over x minus ln y. Just leave it like that. You don't need to do anything. Now what do you divide by? This is the same thing we did before. What do we divide by? We've set it up so we can do this nice division. What do we divide by?
X over y.
Yeah, this. You want that out of there, so what do? Divide both sides. So what do you get? Y prime is equal to 1 over x minus ln y all over what?
X over y plus 3y.
Yeah, x over y plus 3y squared. Stop there. Do not go any further. There's nothing you can do to that to make it any prettier. I know there's this need to make it look nicer. Here's the thing. The reason implicit differentiation exists as a separate integration method is so we can differentiate things that are really, really nasty to isolate in terms of y, like isolating y from them. So can you expect to see some pretty nasty derivatives? Absolutely. Absolutely. They're going to be weird. Stop there. If you wrote that, I would give you full credit right there. There's nothing good to do to that to make it any, quote, better. There's no magical thing. Can you cancel anything? No. No, just stop right there. How's that one? Is that one pretty good? Do you like substituting back in before you start isolating, Natalie? Yeah, it's nice. The reason I want you to start, do you understand why I want you to start that way though? It's really easy to forget things like the product rule. Really easy. Like on that first one, the folium, where is it? Right, where'd you guys do it? You asked about this one at the beginning right here. The 6xy. People mess up the differentiation all the time because what do they forget to do? The product rule, right? You need to use the product rule. By replacing y with f of x, it's another layer to force you to use the product rule. Yes, David? Coming up?